Okay, we are live and we continue solving our neetcode tasks. So let's check the next task for today. Okay, let's share our screen and check. Okay, so let's go to our roadmap and check binary search. So the next task is the following. Let's revoke this one and let's check. Okay, so we are given 2D matrix, M&N matrix, with the following two properties. Each row is sorted in non-decreasing order, okay? The first integer of each row is greater than the last integer of the previous row. And we are given an integer target. We have to return true if target is in the matrix or false otherwise. And we have to write our solution M, N, N. Okay. So what can we do here? So we have the same idea with finding in the matrix. What can we do? We can just find first a row where it can be possible. So first we check a row, and then we check by this row we take and find and try to find our target. Okay, so first idea is find row. So by finding the row, what we need, we are actually need just the first column. So we are going through the matrix. So we take the first column. So we are sending, let's say, matrix, and also we are sending our target. And here it will be our row. And then we just do the binary search and send result. So let's and if there is no such row, we just, if row is equal to -1, we just return false because there is no such value. So let's find a row first. So we have our matrix and we have our target. Okay, so what do? We take column values. So by column values, I mean when I write like matrix 0 row and so yeah, so and 0 value, so it would be the first value, and then the last value in the row. Matrix 0 and matrix length -1, so it will be the last value. Okay, and now what I need to do, let's do the following. So here it will be -1, and here it would be matrix 0 length. So it would be left and it would be right. And while r minus l is greater than 1, yeah, so we do like 2 binary search here. Okay. So we first define the mid value. So as we always know, so mid value would be L and minus R divided by 2 plus L. So it would be our mid index. Then we check if matrix 0 and mid is greater than target, else we do the following. If matrix, if we found actually this value. No? So if we found this value, then we return mid. Otherwise, we return L. Okay. So let's now check. So we take the middle element, so for example 10, and we are looking for 11. So if it's 10 and this target is less, then we move our left, otherwise we move our right to mid. Okay, so here we find our row. So when we found our row, we know and we take this row vels. So row vels will be matrix row. Okay, and now we are doing the same. So we are taking our left, that would be -1, and our right, that would be row vels length. And while r minus L is greater than 1, we again calculate our mid index, L minus R divided by 2 plus L, and here we check if row vels mid, I see that my battery is going down. Yeah, to target, then I just return what I need to return. So here I return true. Yeah. Otherwise, I just return false. Or I can do like, yeah, I return false. And here I check if my row vels mid is greater than target, else. So if it's greater than target, I move my right to mid, otherwise I move my left to mid. Okay, let's check. All right, so we have 25, index -3 out of bounds. Mid, right minus left. And here also right minus left. All right, so here row. So here I see that my left, so with test case 3, it should be 0, 1, and 2, but I return 3. Okay. Line 5. Row. Okay. 13. Okay, 13. So first is 13. So this one, yeah. And if I remove it and just run this one, Okay, false. All right. 7%. Okay, so let's try to solve it actually. Yeah, so here probably should be like this. So here we see false. It's okay, but in this one it's false, but expected to be true. Let's try to find like this row should get us 3, so it should be 0. Let's see what is print first. Check. Okay, so here we see 1, and for this one, 13, it should be 1. 1, 2. Okay. What it would be like this. Okay, so let's, yeah, so for this one it works. Let's check how it works actually. So we calculate our mid. So we take our mid value, so it would be -1. Here it will be 3. So 3 plus 1, 4 divided by 2, it would be 2. Minus 1, it would be 1. Yeah, so we take 10. And target in this case 13. So yeah, so 13 is greater. 13 is greater. So we move our left to mid, that is equal to 1, right? So left is equal to 1. Interesting. Would be it works for all test cases. I suppose it not. Yeah, so it not works even for this test case. Okay. Okay. 4%. So it's 1. My matrix is 3. So 3 minus 1, 2. 1 plus 1, it will be 2. So we take 23. So 23 is greater. So our mid becomes 2. 2 minus 1, 1. And L should be 1. I and Y it's 2. Yeah, I think it should be like this. Yeah, should be different row, but the same column. Here, we remove. And submit. Okay, so it's accepted and works indeed with, so we take first logarithm of this one and then logarithm of this one. So in this case, if our m its number of rows, so log m plus log n. Okay, and we see that it beats 100%. What we have here? Yeah, so here we see that it's much more complicated. Let's check solutions. Okay. Yeah, so with two binary search, it actually works. So thank you very much and see you next time.